So sorry about that, gents. Just had to technical glitch. We'll get going again. So find the probability between 2 and 4. We literally just got to go up to our table from before. We're going to say 2 over 9 plus 3 over 9 plus 2 over 9. Because we want to find the probability between 2 and 4 inclusive. So add those up and you get 7 over 9. Nice. All right, do this one, differentiate. Please don't use the quotient rule. Straight up, don't forget the quotient rule says for a logarithm that you have to have f of x on top, which we don't have. So you've got to use the log laws here. Before I did do anything, for me, I would be just rewriting that. So I'd say d of x is outside of, this helps if I can write properly, ln, and I'm going to say this. I'll do it in 2 steps, why not? Let's say 1 plus x over 1 minus x, and that is going to be to the half. So that goes like that. Now using the log laws, I'm going to use d of dx. I'm going to say a half. The third log law, and I'm going to break this up. Division means minus, so I'm going to say ln of 1 plus x minus ln of 1 minus x. And I'll do that. And now I'll differentiate. So what we can do for that, and don't forget that half is just out the front of everything, by the way. Should be half. Yep. Now differentiate, and that is equal to derivative of ln and x, or 1 plus x, is going to be 1 on 1 plus x. So remember, look at your log laws. Really, we're just looking at the derivative of the inside. That goes on top, and the function goes on the bottom. And then we're going to have minus, derivative of that is minus 1 on 1 minus x. And then from there, we will go is equal to half. I want to get rid of, I'm going to bring these, I want to change that to a plus first, because someone's going to ask, where's that come from? Plus 1 on 1 minus x. And Menzies, you need to learn to do brackets. Unlike denominators, so we've got to cross multiply. So we end up with 1 minus x, and it's going to be all over 1 plus x, 1 minus x. And there's a plus in the middle up top, and this becomes 1 plus x. Now, equals, the x's go away, which is good. That gives us 2 on top. Expand that bracket out, and you get 1 minus x squared. But don't forget, we always had, and I forgot it, the half. And we can see that's going to be really nice because the half cancels off the 2. And then we've got 1 on 1 minus x squared as required. 1, 2, 3. How good is that? So just don't get tricked in because you see a division that is automatically a quotient rule. Okay, so big tip for everybody there. Consider the function of this, find the coordinates of any stationary points and determine their nature. Okay, so with this one, first off, we want to differentiate it. So ddx is equal to 6x squared minus 10x. And we want to set that equal to 0. And I'm going to factorize this out. So I'm going to take out 6x. And then we could say, oh no, I can't take out 6x. And these, slow down. So I'm going to take out 2x. And we're left with 3x minus 5. So therefore we can say x is equal to 0, or 0 is equal to 3x minus 5. So x is equal to 5 over 3. So there we have two of our two stationary points. And what we want to do is we want to check, determine their nature. So we can do that by second derivative test. That's the way I do it. So we want to be looking at, we can find those points as well. Actually, we've got to find the stationary points. So we haven't done that. So we need to do that as well. All right. So you could said find the stationary point, and I haven't done that yet. So to get the sub x equals 0 into the OG, into the original function, and we should get 6. So y is equal to 6 when you sub that in. So our first stationary point is 0 dash 6, and we'll sub 5/3 in, and you will sub x equals 5 over 3 in, and you get y is equal to 37 on 27. 37 on 27. All right. So from there, what have we got to do? We have to go to the second derivative. And we go second derivative, and we'll plug both those bays in. So let's do that. Second derivative, d squared on dx squared. And so that becomes what? 12x minus 10. And then we want to sub in sub x equals sub, oh, what did I put that there for? Sub x equals 0. So we get that becomes minus 10. The fact you got a negative number, hopefully you remember that's a maximum. So we'll say 0.6 is a max, and we can do the same thing when we sub in 37 on 27. Sub x equals 37 on 27 in, and when we do that, we get that is greater than 0. So how do we know that? You can put it into your calculator, and we might as well do it. Where is it? I'll run out of time here. Take my word for it. If you want to check it, check it. But that is greater than 0. So not 0. 6, not 6. 5 on 3 and 37 on 27 is our min. All right. Find any any coordinates, and I need to pause just for 1 second. All right, so finding points of inflection, what do we need to do? We need to set the second derivative to 0, and then we need to check either side of that. And we got the second derivative from the last one. We said d squared, well, if you don't like that notation, do we have it set as f? Yeah, you can just write f double dash of x is equal to, was it 12x minus 10? I believe it was, yep. So set f double dash of x equal to 0. So we've got 0 is equal to 12x minus 10. X is equal to 5 over 6. Any points, so because we're talking about points, we've got to sub that back into the initial equation. So we can say y is equal to, when we sub it back in, we should get something that looks like, we should get 199 and 54. So 199 on 54. So the point there is 5 on 6 and 194 on 54. Now, what do we need to do? We need to check either side of 5 on 6. So if you wanted to just pick, so we're going to say 5 on 6. We know that's a stationary point. Okay, I'm going to pick 0 and 1. So we know that this is, oops, didn't want that. So we know that, we know the answer to this should be 0. Okay, or because that's what we just found, found equal to 0. So what we want when we substitute in 0 into the second derivative, we're just interested in the answer. So we either want a positive answer here, a negative answer here, or a negative and a positive. Doesn't matter. As long as there's a change, it doesn't matter. So if we sub in 0 into the second derivative, we should get minus 10. So obviously that's a negative value. And then when we sub in 1, we should get 2. So the fact that we have gone from a negative through to 0 through to positive, we have indeed a point of inflection. You can say change in concavity, something along the line. Does that for justify? No. You can say change in concavity, point of inflection. All right, and that takes us to the end of day 3. I'm going to put day 4 and 5 up because I've missed a day. Hopefully you guys find this helpful. If not, you still got to do it anyway. So just get prepared for our trials coming up. All right, talk to you guys soon.